This video is about solving absolute value inequalities. Before we start, let's do a quick review of solving an absolute value equation. Remember, if we have an equation like the absolute value of x minus 7 equals 2, we don't know whether the quantity within that absolute value is a positive number or a negative. So we have to split the equation into two parts. We split it so that we have an equation if x minus 7 is positive. We don't do anything then to the quantity inside the absolute value. And if x minus 7 is negative, remember that we take the opposite of that quantity within the absolute value. And we solve both of these two equations. And of course, we have to remember to check both values in the original equation. Let's go back and think about absolute value of x is less than 3. If we think about what that means in terms of the number line, we're looking at all the points less than 3 units from 0 on the number line. That would be everything between 3 and negative 3, less than 3 units. If you look at absolute value of x is greater than 3, you want all of the points more than 3 units from 0 on the number line. That would be everything beyond 3 and negative 3. We'll go back and look at that absolute value of x is less than 3. That graph is a typical graph of an AND graph. And so we're going to be thinking of this as an AND situation. The absolute value of x greater than 3 is the typical kind of graph you'd see with an OR graph. So we're going to think of the greater thans as OR problems. So now if I solve an absolute value inequality, I'm going to start by doing exactly what I did when I solved absolute value inequalities. I'm going to look at when the quantity inside the absolute value, x minus 5, is positive. That means I'm not going to do anything to that quantity. And I'm going to look at that quantity when x minus 5 is negative, and that means I'm going to take the opposite of it. Now I'm going to solve both of those inequalities. But before I do that, I have to remember now that I have two problems, and they're combined by an OR. They're joined by the word OR. And they're joined by the word OR because think back at that graph. When we had greater than, we wanted everything more than. So we had two branches, and that's an OR graph. So now solving it, we're going to have x greater than or equal to 12. On the left side, remember when I want to solve for x, I don't want to solve for negative x. And when I do that, I multiply through by negative 1, and that reverses the inequality. So make sure you remember to do that. Okay, so now I have these two inequalities. I graph them on my number line, and then I make sure that I check the original inequality, and I need to check points from both of the branches of the graph because I've got two little parts going on here. I've got to make sure that they make them both true. Don't go back and check the inequalities after you split them out. Go back to the absolute value inequality to check. Let's look at a little more complicated one. Again, remember we talked about first isolating the absolute value. So I'm going to do that. Now I split it into two inequalities without the absolute value. I split it into the side where the absolute value, the value inside the absolute value is a positive, and where the value inside the absolute value is a negative, and solve. Oh, there's an and joining these two. Why is it an and? Well, it's a less than, and less than means less than that many units away. So that's an and graph usually. So now when I solve it, I get x less than 5, and I get x greater than negative 4. Make sure you graph it, and that you also check. And remember, check in your original inequality. Okay, so let's just recap. When you solve absolute value inequalities, solve like you would an absolute value equation. Inequalities using less than or equal to are connected by the word and inequalities using the greater than or equal to are connected by the word or. Make sure you graph the solution and write the final solution set, and check the original inequality. Don't check it after you split it or after you simplified it. Okay, that's it for now. We're going to have some problems for you to practice. Remember, if you have any questions, talk to a math teacher.